Okay, today let's do some random sums on integration. Okay, random, but yes, I'll try to add something to there. Now let's take the first sum here, and this is something which I think most of you can do. Now whenever we have a definite integration of this order, we have 0 to a fx dx, we can use this formula very easily, because we are tempted, whenever there is a cos here, we try to make it into a sine. Okay. And we recognize that this sine here remains sine. Okay. Now when we add it up, we add 2i equal to this plus this, we get 0 to pi by 2 cos x plus sin x by minus sin 2x dx, right? Now how to do this? Now some people may find it tricky, but I think some of you will recognize that we can write
2 as 1 plus 1 and convert 1 minus sin 2x to sin x minus cos x whole square.
How? We write 1 as sin square x plus cos square x and sin 2x as 2 sin x cos x. So it becomes sin x minus cos x whole square. Now recognize that if you take sin x minus cos x as say a variable t, the sum is easily solved. So what we did here, we used the formulas for definite integration. We just added these two i's, okay, and just managed with the substitution a bit, and we got the result. This is something we do it in definite integration a lot, right? Now suppose we try something like this in indefinite integration. Okay, now how is that? Look at this sum. This is quite a tricky sum. Okay, if you see here, the denominator, if you try to take a substitution here, you substitute this as t, then you get, so it does not bring out the desired effect in a numerator, and there is no other way of doing it actually. We need that somehow here, otherwise this sum cannot be solved. So what do we need? We need something like this here. It's not there. So just think of it like this. Okay, let us take I as this.
Split this I into two integrals.
Name this as I1 and I2. You split it up. So we've split it up, right? What do we require? We require I1. Right? So I1 is going to be I minus I2. Fine. So I we can find very easily, taking this as substitution. Now the problem is with finding out I2. Is I2 solvable? Let us find it out. So to do that, what we do is we multiply in the numerator and denominator by e to the power minus x. Okay. Now when you do that, what happens here? Now if you take this as t, remarkably, we get the numerator here. This is what is I2. So we have our I, we have our I2. Now you get I1 by subtracting these two. So this is something we did in indefinite integration. Okay, we added something which wasn't there and found it out separately. Okay, thanks for watching.